Welcome back. Today we're going to start looking at constants, and we are going to disable Copilot, and then we're going to define a type alias like this, and this is so we can change what exactly a value is later without changing the rest of the code. And so there's two ways we can store values. Let's say we have something like this. How is that going to be compiled? These are quite small. They're just integers. They're just numbers. So they can be stored. Let's say we have our bytecode here. Bytecode. Then we could have some bytecode instruction. That means let's say value, and this is of course actually like some kind of byte value. Let's say that, and then immediately after the bytes for the value itself is stored. And since it's F64, I guess we need 8 bytes. So it would be something like this, with an extra 0. So that's one way. Another way is if we have some like very large strings or something, it's not so nice to store them directly in the bytecode stream. So what you can do is you can have the bytecode, which is like some instructions, and then at the very end perhaps there's like a data region where you will have, for example, string 1 is there, if we call this string 1, and also string 2 and so on. And then when you store this value in the set of instructions, let's say there is something like string 1 plus string 2, you concatenate them, then this will be stored as add, let's say constant, and then the address of string 1 will be the next thing, and address of string 2 will be the thing after that. Also constant probably. So my point is that some values are stored as an immediate value, meaning the bytes for the value are right after the code, the bytecode saying that here's a value. And some constants, they are stored somewhere else in the bytecode, like at the very end or in the very beginning or whatever. And instead of having the bytes for the value immediately in the bytecode stream, there's just a pointer to it. So we're actually going to take the second option, I think, for all the data. So we're going to need to store like an array of values. So I'm going to make another type alias, and this is just a dynamic array to values, something like that. And let's just see that everything still runs, still works, and yeah, good. Just to check that it actually is looking at this file. All right. So what we can just we can do a quick test now. We can say a value array is, let's make a value array of length 8, and let's do something like for I in 0 to 8, I think you can do that. Value array I equals I times 2. And finally we can try to print it. Right, so it doesn't like this because it's an integer and we have to cast it to a float. Index 8 is out of range. Okay, so it's actually... So it's kind of interesting that if you don't include that, it actually goes all the way to 8. So you have to explicitly say that, no, only less than 8. So it's not like Python or anything. Okay, so with that we can make a value array, put things in it. So before we go much further, I actually kind of want to say case realloc, and here we're just gonna return what the allocator normally does. Yeah, this one, this line. And now if we go down here, we should be able to say value array, big value array. Let's have nothing in there, and then we say append to the value array 1 and a couple of more, and then we should be able to print it. Maybe it's not realloc, maybe it's resize. Okay, so that's working. That's just recall that we had our own allocator that kind of intercepted all allocator calls, and it's not doing anything special, it's just exiting if we fail. And actually, how about we do that again? And we'll say fail to resize, and otherwise we return bytes nil. Right. Line 54. Okay, I forgot the equal sign. Mode alloc not supported. What? Ah, I accidentally deleted those somehow. Okay. So that was that. So now what we want to do is take each chunk and associate with it some constants. So that's going to be a value array. And then I think we might want to say something like instructions and maybe we increment it a little bit. Then we want to do for constant in the index as well. Let's say that chunk.constants. Basically want to append some more values. What we want to append now is not the instruction, it is the constant. And in main, when we make a chunk, we also need values. And let's append some values to it. And let's try to run that. So something went wrong, which was that we need a new line here. So now we have some instructions and we have some constants. So I also want to put in a header for that that says constants. Okay, now it looks a little bit better. Instructions, some instructions, and then we have constants stored. And now this chunk thing is starting to get more complicated. So let's say we have a make chunk, which will, let's take a default code capacity, which so we take an initial capacity which defaults to 0. Same for that. And what we're going to return is a pointer to a chunk. So let's say chunk is make chunk and code is make a dynamic opcode with code as 0 length and this capacity, and constants is make a value array 0 length but this capacity, and then we simply return the chunk, but we have to assign those. There we go. Now we also need a delete chunk. And I suppose we should delete chunk code, delete chunk constants, delete chunk. Something like that. And then when we make it here, we should defer delete chunk. And that's quite alright. Let's try to run that. It did not work because there's some kind of syntax error in here. Because I forgot you do like that. It's gonna take a while to get used to. I guess this one is not make, it's a new. Actually here, because it's like a local variable, we don't really need it. So let's start by getting this code to work. I guess it's free then. We free it. Okay, now it's running again. So these functions are just nice to have, especially when this gets larger. And I suppose another thing that would be nice is like add constant, something that takes a chunk and a value, which is a value, and we simply append to the constants here, and it's add constant. We could also have add operation. Takes a chunk and an operation, which is an opcode, let's say, and we just append to the code the operation. And now we could fix up this stuff, but I don't want to do that right now. So now let's try to add an opcode for constants. Now, but as we talked about, what's normally done is that right after the opcode for a constant, in the byte stream, it will look something like this, op constant, and then it will be address. It will be the address of constant. And this guy will just be a byte or a string of bytes or something. We'll define that later, how many bytes exactly. Probably we don't need much more than 2 bytes or something. But anyway, we don't support that yet because the code is just some opcodes. So actually what we should do is to make this really a bytecode array. And then if we want to add an operation, we actually have to cast that to a U8. And another thing we might want to do is to say that the opcodes are using U8 as the kind of a backing value, you can say. So now we also could have something like, yeah, so what do we want to do? So adding a constant should add a constant to the value array. Actually, we might want to do even more than that. Maybe we want to say, first we add this guy. Well, that's not that important which order we add it. So first we add it to the store of constants. Then we can say constant index is just wherever that guy was stored. I think we can do this. And then we want to write some bytes. So let's say append to the chunk the number constant IDX. Okay, let's see if it compiles. First of all, it does not compile because in here we need to change this. So there's the allocator, doesn't really matter. Let's make a chunk with the zero capacity, doesn't really matter. We will delete the chunk in the end. And what I want to do now is, let's say, add a constant. That's basically the only thing we can do now with the chunk, and the value should be 0. Let's add a couple of constants, and once we have that, we can add perhaps an operation, which is the only thing we have right now is return, and all of this I think we can remove. We might want to disassemble it, but let's try to run it now. So there's a problem in here. This should be a U8 array. Now there's some problem with the casting. So interestingly, there's no length. I think then, is it like that? Right, and here we don't need the ampersand anymore because it's just a pointer already. Cannot take pointer address of chunk, which is a procedure parameter. Where did it say that? It said in... Right. don't actually need that. Do we need that? I think we might need that. Given arguments type pointer to chunk, pointer to dynamic. Right, why did I do that? It should be code. And like that. Okay. Here we are. So now we actually need to change something in the pretty printing. So now the byte instruction, we have to turn it into a opcode string, which, can you do this? Now I'm just guessing. Actually, it seems like you can. Bad enum value 2. Okay, so the problem with that is that we are reading the address of the constant as if it were an instruction, which it's obviously not. So we need to change how this works a little bit. Now we need to do this. Okay, but we have to do something, and at the end we will say index plus equals 1. However, if opcode string equals this guy, then we have to do something different. We have to read the address, and I think right now we just used a single byte. Yes, so we can, that didn't mean to do that. Read the address, currently a single byte. Print address next to opcode. And advance pointer 2 steps, 2 bytes. So, with that in mind, let us do the following. So we'll read the address, which is remember this is equal to chunk code index, and the address will then be chunk code index plus 1, and then we can plug that in here. We'll simply put a space and then the value of fmt t printf this thing, and it should just be the address. Then we want to say, actually I can do like that, that's maybe a good idea, because then we just advance the index by 1. This thing will be hit anyway, so let's see how that works. So now we have the instructions, but the counter is wrong. But you see we have a constant, it says load constant 0. Now the values are the same, so just to make a point, let's call this one 3, this one 15, and this one 23. So this one is saying load constant 0, so we go down in the constant section, we see 0, and the value is 3. This one says load constant 1, and so on. Exactly what loading means, we'll find out later. But let us continue. So we have one problem that we'll fix in this video, and then we'll stop, which is that the instruction counter is kind of wrong. So I actually want something like instruction counter to be 0, and then this is the thing that we put in here instead. And that thing should be incremented here. So now we have instruction 0 is a loading constant, instruction 1 is load a constant, and then return. Great. This guy we can get rid of, empty for loop. And I think that's where we're gonna leave it. So I'll see you in the next one.